welcome to another video of Learning to Strong Masala. Yeah, my son is with me and he's disturbing right now. But let's start, okay? Analysis of flow in equipment. Referring to figure 3.8, which is not here. 3.8 is down there. So let's see first figure, okay? This is the figure. You pause it and just look at it, okay? Now, section A will apply to the upper or fractionation section of the tower, and B will apply to the lower or stripping section. B represents vapor, L the liquid, D the upper vapor product, B the bottom liquid product, and X and Y are components. Case 1, analysis of the low pressure column. Section A, rectification. Overall material balance is like this. We'll not go to the technical side of it, okay? We'll just know the gist of it. And the stripping section, so let's look at the figure, okay? So case 1 is fractionation and case 2 is stripping. Yes? 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 Okay, so case 1 is fractionation and case 2 is stripping. So if you look at the case 1, section 1, where fractionation takes place and vapor is going up and liquid is going down, whereas there is feed. In the feed, the same thing is happening, and in the stripping section, vapor is going up and liquid is going down, and heat source is reboiling there. Okay? Very good. And there is case 2, and what is happening here? Nitrogen 99.9% is going from D, and from B 40% of oxygen is going. So there is case 3 as well as, so we'll learn case 3 and let's see, okay? Case 3, analysis of high pressure column. The case of the high pressure column, which is lower, may appear a little easier than the upper column. It should be remembered that the feed may not always be in vapor form. At times the feed into the bottom of the tower may be part vapor and part liquid depending on the process cycle involved. In this case, however, the feed is considered to be all liquid. The bottom part of the operating line, which is given as y equal to F and x equal to B, since the value of yf from equation 3.36 and equation 3.37 gives xb and yf as points on the general operating line. Operating pressure in the tower also plays an important role in calculation of the numbers of trays. The lower operating pressure increases the relative volatility, and it becomes easier to separate the components, which means fewer theoretical plates, or for some number a higher purity for the more volatile component. To determine graphically the number of theoretical plates required, it is first necessary to find the data is applied on 3.1. The mole fraction of nitrogen in the liquid phase in the sump of the tower is on the x-axis. The mole fraction of nitrogen in vapor phase at the top of the tower is on the y-axis. A straight diagonal line is the theoretical operating line. The theoretical operating line represents operation of the tower at the total reflux or zero tower. Okay, this data is applied on figure 3.10. The mole fraction of nitrogen in the liquid phase in the sum of the tower is on the x-axis. The mole fraction of nitrogen in the vapor phase At the top of the tower is on the y-axis a straight diagonal line is the theoretical operating line. The theoretical operating line represents operation of tower at total reflux and zero tower output or feed. The curve joining the operating lines at its ends in the equilibrium line and is somewhat parabolic. At the left of the equilibrium line is the composition of the saturated vapor, leaving the n+1th plate, and to the right of equilibrium line is the composition of the liquid at its bubble point, also leaving the n+1th plate at the same temperature as that of the vapor on the other side of the equilibrium line. The slope of the operating lines are given by the equation 3.18 and 3.19, as are also the interaction of the operating lines with the diagonal. Once operating lines are drawn, the theoretical plates can be included in the diagram, beginning at the value of x and equal to 0.95 or 95% of vapor nitrogen in the product at the top. A vertical line is drawn from the equilibrium line to the upper operating line. This is the first plate. From this point, the horizontal line is drawn from the operating line to the equilibrium line, and a step formation follows until the steps are past the intersection of the operating lines, the upper and the lower. With regards to the lower stripping section, the same procedure is followed, but beginning at the x value of 0.5, which is the nitrogen content in the liquid phase in the sump of the column proceeding upward. At the end, it is found that the stripping section requires 5 plates and the refracting section requires about 10 plates. It is also of interest to note that as the purity of the components gets higher, the number of graphical steps becomes greater, with each steps producing smaller increments in rectification. Thank you for watching. See you in another video. Take care. Bye bye.